Welcome to my video lecture based on Electrical Machine 2, paper code PCEE 501. Today's topic is Introduction to Special Machines. Special machines means those machines are not just very common like three-phase induction motor or single-phase induction motor or transformer or synchronous machines. Apart from those, some machines are specially built for doing some special works like special machines can be AC series motor, special machines can be reluctance motor, it can be stepper motor, and it can be universal motor. Some special kind of work are basically performed by those machines, and those are included in the part of special machine. Myself, Purun Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrasur Institute of Technology and Sports Complex. Formerly, this institute was known as Dr. Sudhir Chandrasur Degree Engineering College, and this institute is under JIS Group. So, let us start with our topic, that is Introduction to Special Machines. In this topic, we will just briefly highlight with some special kind of machines, and we will cover those parts. So our first topic is on reluctance motor. Reluctance. Basically, this term is related to magnetic reluctance or the resistance offered by the magnetic flux, that is known as reluctance. And the motor which will build on the principle of this reluctance effect of electromagnetism, that will be known as reluctance motor. So let us see how this reluctance effect can be being the mechanism of a motor principle. Small size single phase synchronous machines is known as reluctance motor. A single phase reluctance motor is basically same as single phase cage type induction motor. The stator has main winding and auxiliary winding. The rotor of a reluctance motor is basically a squirrel cage motor with some teeth removed at appropriate places, such as to provide desired number of salient poles. That means the reluctance motor, as per construction, it is almost similar to single phase cage type, squirrel cage type induction motor. And like that, it has two windings, main winding and auxiliary winding. The only difference part in reluctance motor is it is squirrel cage type motor with some teeth removed at appropriate places, such as to provide the desired number of salient poles. So that is the main fact. Here, teeth has been removed in 4 places and it becomes 4-pole salient pole motor. When the stator is connected to a single phase supply, the motor starts as a single phase induction motor at a speed of 75%. Centrifugal switch disconnects the main and winding from auxiliary winding. Now the motor continues to rotate with main winding. When the speed is close to synchronous speed, a reluctance torque is produced due to tendency of the rotor to align itself in the minimum reluctance position with respect to the synchronously rotating flux of the forward field. Rotor pulls out into synchronism. For this to happen effectively, the rotor load inertia must be within limits. When the speed is close to synchronous speed, the reluctance torque developed as a synchronous motor pulls the motor into synchronism and the rotor at synchronous speed. That means the fact happens physically. The diagram we have shown, that is in four places teeth are removed. That means this will behave as a four-pole machine. So this will behave as a four-pole machine. And at the beginning, it is connected with single phase supply. So the motor will start as a single phase induction motor, and like any other single phase induction motor, when the motor reaches 75% of the speed, the centrifugal switch disconnects the main winding from auxiliary winding. It is similar for all kind of single phase induction motor, effect apart from shaded pole. So now the motor continues to rotate with main winding. When the speed is close to synchronous speed, a reluctance torque is produced, and due to the tendency of the rotor to align itself in the minimum reluctance position with respect to the synchronously rotating flux of the forward field, rotor pulls out into synchronism, and for this to happen effectively, the load inertia must be within the limit. And when the speed is close to the synchronous speed, the reluctance torque develops as the synchronous motor pulls the rotor into synchronism. That means due to the reluctance torque, the induction motor will now behave as synchronous motor. It will achieve the synchronous speed due to the effect of reluctance torque, and the rotor will achieve the synchronous speed. So that is the basic changes in case of reluctance motor and with single phase induction motor. In reluctance motor, the field DC excitation is not needed. Like synchronous motors, it needs DC excitation, but in case of reluctance motor, it does not need any kind of DC excitation because it is starts with the principle of single phase induction motor. We have already seen that the motor starting principle is just like single phase induction motor. So definitely it does not need any kind of DC excitation. So the power factor of this motor is lower than that of the equivalent induction motor. The main disadvantage of the reluctance motor are it is simple construction, no slip ring is required, no brushes, no DC winding, and low cost and easy maintenance. So these are the basic advantages of the reluctance motor. Reluctance motor has many uses for its constant speed operation, such as clock timers, signaling devices, photographs, etc. This is the torque speed characteristics of the reluctance motor. We can see that in the torque speed characteristics, the first part of torque and speed when the motor is running with main winding plus auxiliary winding. It generates a particular flat kind of torque, and after that the auxiliary winding is removed, and due to the reluctance effect, the reluctance torque is developed. So the amount of torque is increased and the motor is run itself by its main winding. And the nature of torque speed characteristics is like this. Okay. So this is about reluctance motor, and it is basically single phase synchronous motor, but its meets the principle for starting as single phase induction motor, and then it develops the reluctance torque and it will achieve the synchronous speed. So ultimately it behaves as a single phase synchronous motor. Now we will come to our next topic, that is hysteresis motor. Like reluctance, another effect we know that for any kind of electromagnets, there is a loss, that is hysteresis loss and eddy current loss. And that hysteresis loss comes because of the magnetization and demagnetization effect of electromagnets. And due to that, magnetization and demagnetization, a hysteresis loop is developed. And that hysteresis loop is now we will taking for our motoring action. And how this hysteresis action of electromagnet will help a motor to develop its rotating magnetic field and moving on, that we will see in hysteresis motor part. Hysteresis motor is basically a synchronous motor with uniform air gap without DC excitation. In hysteresis motor, the torque is produced due to hysteresis and eddy current induced in the rotor by the action of rotating flux of the stator windings. A hysteresis motor is basically a synchronous motor with uniform air gap without DC excitation. Remember, hysteresis motor is a synchronous motor with uniform air gap but without DC excitation. In hysteresis motor, torque is produced due to hysteresis. Here our torque is produced due to hysteresis, and eddy current is induced in the rotor by the action of rotating flux of the stator winding. That means here we will use the factor that is hysteresis, and that will develop the speed of the motor or develop the torque of the motor. The stator of the hysteresis motor is designed to produce synchronous revolving field from single phase supply. The stator of the hysteresis motor is designed to produce the synchronous revolving field from a single phase supply. Stator has mainly two windings, main winding and auxiliary winding. The rotor of hysteresis motor is made of magnetic material that high hysteresis loss property, such as cobalt steel or alnico or alloy. That means the rotor will basically utilize the phenomenon of hysteresis loss, and so we will use the material which have high hysteresis loss, and those materials are cobalt steel or it may be alnico or alloy. And hysteresis loss become high due to large area of hysteresis loop. When we will use this kind of material, definitely the hysteresis loop area will be increased. So hysteresis loss definitely increased. Now rotor does not carry any winding or teeth. The magnetic cylindrical portion of the rotor is assembled over the shaft through the non-magnetic materials like brush. Rotor is produced with high resistance to reduce eddy current loss. So this is our rotor, which is made of chrome steel, and this part is the air gap we have shown here, and this is our stator, and this one is shaft. This is the hysteresis ring formed in the rotor, and this is the aluminium as bar. Now it has been shown that hysteresis loop of the rotor material. We have already said that the hysteresis loop will be very larger area because we will take the path of hysteresis loss for our rotating principle. So hysteresis motor starts like a normal single phase induction motor. When the speed of the rotor reaches near about synchronous speed, the stator pulls the rotor into synchronism. And at the time of rotor's rotation at the synchronous speed, the rotating magnetic field flux in the stator produces poles on the rotor by induction. For high residual magnetism or retentivity, the rotor pole strength remains sustainable or unchanged. Again, higher the retentivity, higher is the hysteresis torque, and the hysteresis torque is independent of the rotor speed always. As there is no slip at steady state running condition, only hysteresis torque is present to keep the rotor running at synchronous speed, and it behaves like a synchronous motor. Like the reluctance motor, the hysteresis motor also start with the principle of single phase induction motor, and when the motor reaches the speed near about synchronous speed, the stator pulls the rotor into synchronism with the action of hysteresis loop or hysteresis law. At the time, rotor rotation at the synchronous speed with rotating magnetic flux in the stator pulls on the rotor by induction. For the high residual magnetism or retentivity of the rotor, pole strength remains sustainable or unchanged. We have used those material which will retain the magnetism. Due to that, it has higher hysteresis loop. So the pole strength remains unchangeable or sustainable. Again, the higher retentivity and higher the hysteresis torque, and due to that retentivity, it will produce higher torque in the rotor side. Due to that additional torque, the rotor will achieve the synchronous speed. It will increase the speed and it will achieve the synchronous speed. As there is no slip at steady state running condition, only hysteresis torque is present to keep the rotor running at synchronous speed, and it behaves like a synchronous motor. Okay, so that's all about our hysteresis motor. So in this special machine lecture, we have studied about the two types of special machines, and those are hysteresis motor and reluctance motor. In both cases, their starting principle is just like single phase induction motor, but at the time of running, they are behave like a they are behave like a synchronous motor because they are achieving the synchronous speed while running. So for fast case, reluctance motor is achieving its synchronous speed with developing additional torque by means of reluctance. And in case of hysteresis motor, it will develop the additional torque with the help of magnetic retentivity or higher hysteresis loss. And due to higher hysteresis loss, the materials have higher retentivity, and due to that higher retentivity of the magnetic flux, it will definitely develop the higher amount of torque, and that torque will help the motor to achieve the synchronous speed. So these are the two basic things we have taken into account for develop our single phase induction motors to behave like synchronous motor with help of some magnetic properties like reluctance and hysteresis loss. In my next lecture we will also study about some special machines, and we will learn that how some special properties will help the motors to develop its uniqueness. So that's all about uh, for today's lecture. Thank you all for listening my lecture, and welcome you for my next lecture onwards for special machines. Thank you all. Thank you.